This lecture is about sequences and series of elements. First one is about sequences and what they are. The material is in the book in section 9.1. Now, what is a sequence? A sequence is an ordered list of infinitely many elements and these elements are indexed by 1, 2, 3, etc. by the natural numbers. Now, the notation that we generally use is as follows. So we can write a sequence as A1, A2, and so on, or more compactly by A indexed by n, where n ranges from 1 to infinity. Of course, we can start the sequence by n equals 0 as well. It's not very important. And of course, these elements can be anything, but we will mainly consider real numbers. I will give some examples. First example is the sequence A1 equals 1, A2 equals 2, and so on. In general, AN equals n. The second example can be A1 equals 1 squared, A2 equals 2 squared, and in general AN equals n squared. So we have a sort of prescription for describing this sequence. The third example is A1 equals 1 over 1, A2 equals 1 over 2, and in general AN equals 1 over n. Of course, it's not necessary that a sequence has a certain recipe, obeys a certain recipe, because we can just take anything. But of course, in our applications, it will always have a specific form. Now let us consider some characteristics of sequences. A sequence AN is said to be bounded below by number L if the following holds. If every element of the sequence is at least as large as L for all indices. The sequence is said to be bounded above by U if every element of the sequence is less or equal to U. And we say that the sequence is simply bounded. We can also bound it by a constant k if it is bounded above by k and bounded below by minus k, or in other words, if the absolute value of AN is less or equal to k for all indices n. Now we can say something also about when a sequence exhibits a certain pattern. And we call it either non-decreasing. So the pattern is non-decreasingness. And when does that happen? If every successive element from the sequence is at least as big as the previous one. It is increasing if every subsequent element from the sequence is larger than the previous one, strictly larger. It is non-increasing if every subsequent element from the sequence is not larger than the previous one. And it is decreasing if every subsequent element from the sequence is smaller than the previous one, strictly smaller. Now the problem is that there is not a complete unicity in definition here, because sometimes people mean non-decreasing if they say increasing, or such thing happens, and you always have to be careful what the precise definition is. Now which of these features are exhibited by our examples? Well, if you look back, then examples A and B are both bounded below by 0 or by 1. They are not bounded above, and they are increasing. The last example is bounded above and below, so it's bounded in fact by 1, because every element is, well, the sequence only consists of positive elements, they are all bounded by 1, so that's quite easy, and in fact this is a decreasing sequence.